Let's take a look at some of the functions that we sketched in class. So we start out with just the function f of x is equal to x squared, your basic parabola, which is symmetrical around the y-axis. The reason for that is because values of any value, positive value, its y value is going to be equal to the value when we plug in that x value is opposite. So -2, x equals -2, and x equals +2 have the same y value. No big surprise there. And this is going to happen actually whenever we have an even exponent. What happens when we have an odd exponent, x cubed, is that this branch on the negative side flips down so that the y values are now negative. And now instead of having a reflection across the y-axis, we have what's called rotational symmetry, which is to say that if we rotate this thing 180 degrees, it comes back onto itself. And the reason for that is that now if we plug in a given x value, let's say 2, which would have a value of 8, now when we plug in the opposite of 2, or -2, we're going to get -8. And that's going to be true whenever the exponent here is an odd number. So if we look at what happens is we just go from an odd to an even to an odd, you can see that all that's happening is the left side of this function is just flipping up and down over the x-axis. You'll see also that as the exponent increases, the function gets tighter and starts to look more and more like almost the bottom of a rectangle. And the reason is that when x is less than 1, when we raise it to the 15th power, it stays very close to 0. But as soon as we get above 1, raising it to the 15th power, our values just zoom up. So other than that, though, there's a lot of similarity between a to the 12th, a to the 10th, a to the 8th, a to the 6th, a to the 4th, etc., a squared. Even when we get to a to the 1st, we can see we still have rotational symmetry here, just like we did with a to the 3rd or a to the 5th, etc. And when we get to a to 0, we still have reflection of the function across the y-axis. Now what happens when we go negative is that we're going to see something similar. As we cycle down through the even and odd, we are again going to see this pattern where we have the left side, one part of it all flips up and down over the x-axis. And so when x is, let's say, or when a is -7, we again have rotational symmetry. So this thing rotates on itself if we rotate around the origin 180 degrees. And again, when we have this exponent being even, we have the symmetry across the y-axis. Okay, so this basic shape here of x to the -2, this is called the volcano for reasons that I hope you can see. And then we get this thing when we have a to the -1st, a to the -3rd, a to the -5th, etc. And again, we have a discontinuity because when we have x to the -2, that's the equivalent of 1 over x squared, which means that our function is not defined when x is equal to 0. And that'll be true for all of these where our exponent is negative. Okay, so you should have a general sense of what x to the -1 looks like, x to the -2, and then you should be able to surmise what it looks like as the exponent goes up to -3, -4, etc. And then the same on the positive side. Okay, our next set of functions, or our next function, are these ceiling, round, and floor functions, the so-called step functions. And the idea here for the floor function is that any value, let's say we take 0.5, its y value will just be equal to the next integer down to the left on the number line. So anything from 0 up till just before we reach 1, the function has a value of 0. It's open here, and as soon as we hit the value of 1, we jump up. So the function now has a value of 1, and it stays like that until it hits 2, etc. So you can see we have closed points on the left side of each of these steps, open points on the right side. So this is the floor function, and again, what happens is you pick any value, and the value of the function at that x value is just equal to either the x value itself, if the x value is an integer, or the next integer to the left going down the number line. The round function, which is more familiar to you, is how we round a number that's not an integer, or an integer as well. So let's say we have the value of 1.2. Well, that we know rounds to 1. As soon as we get to 1.5, we're going to start rounding up to 2. So at exactly 1.5, we jump up to 2, but everything up to 1.5, we stay at 1. So that's why we have an open circle again here at the right side of the step, and then closed at the beginning of the step. So the function is, it's not continuous, but every value of x has a y value. So its domain is all real values. There's no value of x that we could plug in that won't give us a value for y. And then the ceiling function, similar, except that now any number we pick, let's say 1.2, the value of the function goes up to the next highest integer. So in this case, it would be 2. It stays at 2 up through 1.7, 1.9, etc. And it stays there even as we hit 2. But as soon as we go a little bit above 2, we jump to the next integer of 3. And so we're getting an open circle on the left side, a closed circle on the right side. So again, ceiling, round, floor. And I wouldn't spend a lot of time worrying about the exact ins and outs of this, like which side is open or closed. Just have a general understanding of how these functions work. Okay, our next function, or group of functions, are the functions of a to the x, where a is some number as the base, and then we raise it. The exponent is the variable here. So here we have 2 to the x, and what we can see here is that we have the point 0, 1, because when x is 0, 2 to the 0 is equal to 1, and that'll be true no matter what our base is. So whether we have 3 to the x, or 4 to the x, 5 to the x, etc., they all pass through that point 0, 1. What happens as the base gets bigger is that the function gets steeper. Now what happens on the left side is that when we have a number that is negative, so let's say 2 to the negative 1, that's equal to 1 over 2, which means that we get an x value here of 1/2. When x is negative 2, that's equal to 1 over 2 squared, so we get a y value of negative 1, or a y value of positive 1/4. At negative 3, we get positive 1/8, etc. So this gets closer and closer to 0, but never reaches it. And the other thing we find is that any y value here, so here where we have a y value of 1/4, if I go to the opposite side, to the opposite x value, I'm going to get the reciprocal. So here we have a y value of 4 when x is 2. When x is negative 2, it's a y value of 1/4. And so that's how these work. They all have the same basic shape. They just get steeper and steeper. Okay. On the other hand, what happens when we have a base that is between 0 and 1, like 1/2, now basically this thing is equal to the reciprocal of 2 to the x. So now when we have 0.5 to the first, that's 1 over 2. 0.5, or 1/2 squared, is 1 over 4. But 0.5 to the negative 2 is 1 over 0.5 squared, which means it's 1 over 1/4, which means it's 4. So these two functions are just reflections of each other across the x or the y-axis. So we have 2 to the x, 1/2 to the x. Here we have 3 to the x. Here we have 1/3 to the x. So again, we have just reflections of each other across the y-axis. Okay. Next function here, we looked at something where we had the square root of some number squared minus x squared, or this would be the square root of 4 minus x squared. What that gives us is the top half of a circle here. And the radius is just this number here That's the number that we're squaring. In order to get the bottom half of our circle, then we have to graph the function negative square root of 2 squared minus x squared, because neither one of this alone would give us the full circle. Each of these gives us half of the circle. This one gives us where the y values are positive, this one where the y values are negative. And as we change the value of c, 2.5 squared, 3 squared, what we see happening is that the radius of the circle is increasing. Notice that the center is still staying at 0, 0, but what we would have to do would be replace x with, let's say, x minus 1, that quantity squared, if we wanted to move the circle, for example, 1 unit to the right.